This is lesson 27, session 2, making a line plot. To start today, what is the greatest value in the list of data below? How many x's would a line plot show for that value? So our values are 3/4, 1/2, 5/8, 3/4, 4/8, and 1/2. Pause the video, solve the problem, and then come back here and we'll work through it together. Okay, I'm going to start by putting my line here for my line plot. And then I see that these can be measured in eighths. So the unit of measure I'm going to use here is eighths. So I'm going to start down here with 0. And then we're going to go 1, 2, 3, 4, 5, 6, 7/8, and then 8/8 is the same as 1. Okay, so for each one of these data points, we're going to put an X on our line chart here. So this is 1/8, or a line plot. And then 2/8, so this is 2/8, which is also the same as 1/4. And then this is 3/8. And then here we have 4/8, which is the same as 1/2. And then 5/8, 6/8, which is the same as 3/4. And 7/8, and then 8/8 is 1. So for each of these values, we're going to put an X on the line plot, and I like to cross each one out as I'm using them. So then if I get distracted or I lose my place, then I don't repeat any. So the first one is 3/4. So here's 6/8, which is 3/4. So we'll put an X there and cross that out. 1/2. Right here, 4/8 is 1/2. And we'll cross that out. Okay, 5/8 right here. Good, we'll cross that out. 3/4 is the next one. Let's see, 3/4 is 6/8. We'll put another X there. And then 4/8 is 1/2. There we go. And then one more, 1/2. X right here. So there's our line plot for those values, and it says, what is the greatest value in the list of data below? So the greatest on our plot is up here, but the greatest one that has value is right here. It's the 6/8 and 3/4. So the greatest value is this one right here. So we'll say the greatest value is 3/4. And then it says how many X's would a line plot show for that value? So here we have 2 X's, and so it has 2 X's. Okay, on the top of page 557, this is the try it. Kira bought 12 different types of stickers to decorate her scrapbook. She measured the width in inches of each type of sticker and wrote down the results. Make a line plot to organize and display Kira's data. So I am looking at these values over here, and we have some options of what we want to divide our line plot into. But I see that the biggest one here is eighths, and so I think eighths is what I'm going to use. It's kind of the same as what we did on the last problem. We'll divide this up just the same way. So here's 0, and then 1, 2, 3, 4, 5, 6, 7, 8/8. So 0, Okay, now we're ready to put the values onto our line plot. So we'll start with 1/4, which is right there, and then 3/4. 3/4 is over here. 1/8 down here. 1/2 right there. 3/4 right there. 1/4. Okay. 1/2 here in the middle. There's a 1. 3/8. Okay. 5/8. That's the first one for that. 1/2 gets another one. That one's in the lead so far. And 1. Okay. So hopefully the line plot that you did in your book looks just like the line plot in my book. Model It is at the bottom of page 558. List what you know and plan how to make the line plot. So we just did that, so we're going to kind of talk through the process now of what we just did. The fractions are in eighths, fourths, and halves, so we know that. The narrowest sticker is 1/8 inch, the widest sticker is 1. The line plot will start at 0 and go up to 1 inch. The line plot will show an X for each of the 12 stickers, and the line plot will have a title and a scale label. So what we just did here is what they're just describing. So use your plan to start labeling and marking the line plot to display the data. Draw a number line from 0 to 1. Choose an appropriate scale for the data. Graph each data value. The line plot shows the first row from Kira's list of sticker widths. So there's the sticker widths, and we are measuring sticker widths, and our unit that goes down here is we are measuring the width using inches. It's the width in inches. So if we're thinking of these as eighths, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I just magically filled in all of the values here, and the first row, 1/4, there's the X there. 3/4, they have the X here, and 3/8, they already put in the X here. So we'll just go through the rest of them. Maybe I can make this go really fast. Hey, there we go. It looks just like what we did on the previous slide. Okay, connected, which is on page 559 in your workbooks. Number 1, look at the first model it. Why is it a good plan to go from 0 up to 1 inch for the line plot? All the stickers are from 0 to 1 inch in width. There are no stickers that are less than 0 inches, and there's no stickers that are greater than 1 inch. Number 2, what scale is used for the line plot in the second model it? Explain. We used a 1/8 inch scale because there are 8 equal sections from 0 to 1, and we found that our fractions were all equivalent to eighths. Number 3, why does the scale make sense for the data? The scale makes sense because all the stickers can be shown in eighths using equivalent fractions. Number 4, the tick marks in the second modelet are not labeled with fractions. Do they have to be? How can you locate data points with X's when the tick marks are not labeled with numbers? So you do not need to label all the tick marks, even though we did. You can count eighths to locate the data points. For example, 1/4 is equivalent to 2/8, so you can plot an X on the second tick mark after the 0. Although I am going to tell you that if they are not labeled and it's easier for you to have them labeled, then go ahead and label them. Number 5, Complete the line plot in the second model it. Include the rest of the data, a title above the line plot, and a label for the scale below the line plot, which we did. Number 6, how do you use a line plot to organize measurement data? A line plot shows the data in order from least to greatest value. The X's show how the data are distributed among the different measures. It's very easy to see the data at first glance. Number 7, reflect. Look back at your try it strategies by your teacher and model it. Which models or strategies do you like best for making line plots? And explain. Number 8. Sean records the lengths and inches of several bugs he collects for a science project. Complete the line plot of the data. Okay, I want you to pause and try this one on your own, and then when you have your solution, press play again, and we'll see how you did. Okay, I am going to label this bug lengths because that's what we are trying to figure out. And our measurement goes at the bottom. We are measuring it in length in inches. And I am looking at my line plot here, and I see the whole numbers 1, 2, 3, and 4, which makes sense because there's nothing smaller than 1, and there's nothing greater than 4. And I'm looking at the fractions, and I am going to choose to divide each of these whole numbers into eighths again, because I see my small unit fraction here is eighths, and all of these fractions can be equivalent to eighths. So we'll divide this. Okay. And let's go ahead and start plotting. So 1 and 5/8 will be 1 and 1, 2, 3, 4, 5/8. Notice I'm not going to take the time to label all of them. And we're going to cross that out so we don't lose track of our spot. 3 and 1/4, so we start at the 3. Now 1/4 is the same as 2/8. If I multiply both the numerator and the denominator by 2, I'll get 2/8, so that's 1 2/8. And we'll cross this one off. 1 and 3/4. 3/4 is the same as 6/8 if I multiply those both by 2. So I'm going to count 6, 1, 2, 3, 4, 5, 6. Okay. There's 2 and 7/8. There's 2, and I know 7 is right before we get to the 3. It's going to be the last one. Okay. 1 and 3/4. We know that 3/4 is the same as 6/8. There's 1 and 1, 2, 3, 4, 5, 6, right above that one. Okay, 3 and 1/4. 1/4 is 2/8, so it's above that one. And then 1 and 5/8. So 1, 2, 3, 4, 5 is above this one. Seeing some clusters of lengths here. 2 and 3/8. So here, start at the 2, and then 1, 2, 3, and then just 1. That looks like an outlier. And then 1 and 6/8, I remember, is this one right here, because 8, 7, 6. All right, so your line plot should look just like my line plot. Number 9, last problem. Dolores trains for a 5-mile race. She keeps track of the distances she runs each day, in miles, in a training log. Use the data to make a line plot. Show your work. So, let's see, what is our smallest one here? Well, actually, please pause, figure it out, and then press play and see if yours matches what I do. So I'm looking at mine here, and I see 4 is my smallest whole number here, and there's nothing smaller than 4. and 7. It's bigger than 7, but less than 8. So we're going to have to go from 4 to 8 here. So here's 4, 5, 6, and 7, and there's 8. Okay. And looking at the fractions, the smallest fraction unit we have is fourths. The other ones are halves. And so I know halves can be equivalent to fourths. So we're going to make everything into fourths. So we won't want to use halves because then we wouldn't have a spot to put these 1/4. All right, let's go ahead and start plotting then. So let's see if I can do this real fast. So that is the end of the blue pages for Lesson 27, Session 2. Your assignment is to complete pages 561 and 562 on your own. Remember that the answer key is going to be on Google Classroom. However, if you get finished ahead of time and you want me to send it to you individually, I will, so that you can check your work and let me know if there's anything that you're struggling with or any questions that you have. I will see you for Session 3.